43, we're going to talk about equivalent division problems, as well as find unknowns in fraction and decimal problems. The following two division problems have the same quotient. We call them equivalent division problems. Now, which problem seems easier to perform mentally? 700 divided by 14 or 350 divided by 7? I would hope that most of you, or all of you, are saying that one, because I know that if I write it out, that 7 is going to go into that 35 5 times, and I do my 0 there. Where if I write the other one out, I don't know how many times that 14 is going to go into 70. Not off the top of my head anyways. So we can change problem A to problem B by dividing both 714 by 2. So when I divide both 700 by 2 and 14 by 2, I end up with problem B. By dividing both the dividend and the divisor by the same number, in this case we did 2, we formed an equivalent division problem that was easier to divide mentally. This process simply reduces the terms of the division as we would a fraction. So as you see, I have 700 over 14. I divided both of them by 2. Okay, so I divided by 2 here, and I divide by 2 there to get this fraction or the division problem that's easier for me to do. We may also form equivalent division problems by multiplying the dividend and divisor by the same number. So before we were dividing by the same number, now we're going to multiply by the same number. So look at the following equivalent problems. 7 1/2 divided by 1 1/2, or 1/2, and then 15 divided by 1. I would hope that you're thinking that problem D is easier. Okay. We change problem C to problem D by doubling both 7 1/2 and 1/2. That is, by multiplying both numbers by 2. So I did 7 1/2 times 2 and 1/2 times 2 to get my 15 over 1. So this process forms an equivalent division problem in the same way we would form an equivalent fraction. Okay? So we're thinking of it as fractions and multiplying by that number, that fraction that's equal to 1. So this says form an equivalent division problem for the division below. Then calculate the quotient. Okay? So if I think about this as 1,200 divided by 16, I have to think about how many times 16 goes into 120. That seems hard to me. If I put in a fraction, okay, right away, I know I can divide both numbers by 2. Okay? If I divide this by 2, I can divide that 12 by 2 and get 6 with 2 zeros still. And I divide 16 by 2, we're going to get 8. Okay? So now I have 600 divided by 8. A little easier. Let's see if we can make it easier. Divide both by 2 again. So now I get 300, I get 4. Okay. A little easier. I have 300 divided by 4. A little easier. I could divide by 2 again. Okay. I'll get 150 divided by 2. Gets easier. Okay. So either one of these would work as an equivalent problem. Now, calculate the quotient. I can pick any one of these. Let's do the 150 divided by 2 goes in there 7 times, goes 75. If I do this one, 7, notice I still get 75. No matter which one of those problems I do, I'm going to get the same answer. You just want to get it to numbers that are easier to do. This one's hard. Those 3 are a lot easier. Notice that several equivalent division problems can be formed from the original problem. Okay? So I talked about how these 3, they're still equivalent, and they're a lot easier to do than our first original problem. Form an equivalent division problem for the division problem below, then calculate the quotient. Okay? when I see halves, I'm going to think, first of all, I don't even know how to divide fractions yet. So I'm not sure what I'm going to do. Well, when I see a half, I know I can multiply by 2 and I'm going to get a nice whole number. Okay? So 7.5 times 2 is going to be 15 because I can add 7.5 plus 7.5. Okay? 2.5 times 2 is going to be 5. Show my work over here. Okay, now I have 15 divided by 5. That's easy. 3, done. This much easier than that problem. Okay, 1, because we haven't even gotten over division of fractions, and 2, this is mental math, and that's not even close. Now, going into unknown numbers. Have we found unknown numbers before? Absolutely. We did in whole number problems right at the beginning of the year. Okay. Now we're going to find unknowns in fraction and decimal problems. The same exact concept. So I have d minus 5 equals 3 2/10. Okay. Thinking back to before, if I don't know this number, okay, I need to add my other two numbers to get that number. Okay, because that's my big number in my subtraction problem. So all I need to do is take my 5, my 3 2/10, line up my decimal points. I get that d is equal to 8.2. Now, I can check my answer mentally. I can do it physically. Either way, I should see that it makes sense. If I did it mentally, 8 minus 5 is 3. 8.8 2/10 minus 5, 3 2/10 makes sense. Okay, it works. Fractions. I have f plus 1/5 equals 4/5. Well, remember, if I don't know one of my add-ins, I need to do some subtraction. I take what the sum is, subtract whatever add-in I know, and that's going to give me my unknown. When we subtract fractions, remember, the denominator stays the same. We just subtract the numerators. 4 minus 1 is 3. Answer is 3/5. Does it make sense that 3/5 plus 1/5 is 4/5? Absolutely. 3/5 n equals 1. What is this question really asking for? When do we have a fraction times an unknown number equals 1? Remember when we had problems that looked like that? Isn't this box the same as having that letter n there, an unknown? Absolutely. We're asking for the reciprocal. So all we need to do there is write our answer of 5/3. And when we have a number and a letter stuck together, there's no sign in between. Remember, it's multiplication. So here, all we're asking for is the reciprocal. We just flip that number. We leave it as an improper fraction. The only time we don't leave it as an improper fraction is if we have a number over 1, then we need to make it a whole number. Go ahead and do practice set. Bring whatever problems you have to class. This is actually supposed to be a subtraction sign. There.